So, first of all, I would like to thank EMERTEX Technology for providing us such an internship on an embedded system to work on a project Microwave 1. Myself, Shreyash Kadu. I am a student of Government College of Engineering, Nagpur. So, here we begin with microwave oven stimulation. First of all, I would like to describe what I learned in this internship project by showing my PPT. So, first of all, in content, we studied about the basics of C programming, embedded C programming, microcontroller and microprocessor, embedded system and interfaces, and microwave oven project simulation. So, first of all, what is C? It is a widely used programming language developed by Dennis Ritchie in 1972 at Bell Laboratory. It is used in system software development, embedded software development, OS kernel file system development, etc. It supports functions that enable easy access of code. It is a combination of ALGOL and basic language. There are various types of data type, number system, conditional construct, and many more features for building problem to solve the problem statement. Here we ideally use the function. Function is used to perform a specific task. It will reduce our long code into shorter format. So in our microwave project, we have used a function in various steps. Here we didn't use any pointer, but it is also used in C programming language, but even in our project, it is of no use. So these are the topics which I will show that what I learned in microwave oven. So first of all, it begins with the basics in which it talks about a header file, its preprocessor and many more. Then it begins with a variable and constant and its tool. Then ma'am taught us about the data types, input and output functions such as printf and scanf, operators like assignment operator, conditional operator, relational operator, and many more. So then we after begin with a control statement. Here we use while loop, if else statement, and many more. Now it begins with a function. The function as taught by ma'am in a vast and very deep with a basic its programming as well as its understanding. Now we begin with an array. Array is a collection of an homogeneous of same types of data. Then we begin with string, which is also a character of array, and now with pointer. So here we begin with now embedded C programming. No, now first of all, I would like to tell about its project requirement. Here we use various types such as MPLAB XID, XCIT compiler, PIXIMLAC microcontroller PIC16F877A, 16 into 4 CLCD, and MKB and timer 2 and tactile switch, which help us to develop our microwave oven project. Here it is shown that it is that microcontroller PIC16F877A is a 40-pin IC, and we have used many of our switches in our project or its pin. So let's begin with an embedded C programming. When the conventional C language is used for programming of embedded system, it referred to as an embedded C. It directly manipulates the hardware and memory address. We can access the registers of the microcontroller and perform a given task in embedded C. So now we let us understand what is the difference between the microcontroller and microprocessor. So microcontroller is an heart of embedded system, and embedded system is a combination of hardware and software which is used to perform a specific tasks, while microprocessor is a heart of computer system. Microcontrollers are used in small, minimum component design performing control-oriented applications. A CPU built into a single VLSI chip called microprocessor. It performs arithmetic logical unit operations and communicates to other devices connected with it. It uses an external bus to interface random access memory, read-only memory, and other peripherals. So let's begin with what is an embedded system. So as I already tell that it is a combination of hardware and software which is used to perform a specific task. Assembly language was a pioneer, but recently majority of work in embedded system is done using C, C++, etc. There are various types of embedded system, real-time, standalone, network, mobile. Ma'am has also defined and explained us in brief. So what are the when we are working on a microcontroller, interrupt are arises due to many of the issue. So its block diagram I had already shown here that interrupts are mainly occurs in hardware and software. In hardware it is of polling and vector, while in software it is a trap or extraction. It is a communication process set up in a microprocessor or microcontroller in which an internal or external device requests the microprocessor or microcontroller to stop the processing. Then the microcontroller and microprocessor acknowledge the request and attend to the request. Now, a question is created in our mind that what is polling? So it is the process where a computer or controlling device waits for an external device to check the line or state, often with a low level hardware. So this is about interrupt. Now we will begin with what is CLCD. So in our project we have used two CLCD of 16 into 2 and 16 into 4. So it stands for character liquid crystal display and used to display all ASCII character. ASCII is the American standard code for information interchange and symbols. So it has totally 16 interfacing lines. Controller can execute the data and instructions according to our code. So D0 to D7 are data line and has two types. I had already told, the 16 into 4 and 16 into 2. So RS line are register select line. When we give our RS value, it will show as a data. When RS value is 0, it will show as an instruction. So here I have shown that this is an CLCD source. So we will begin with the ISR. So IRS stands for interrupt service routine. Here it is block diagram that how it works. An ISR is a software routine that hardware involves in response to an interrupt. It attends the request of an interrupting source by clearing the interrupt flag and should save register content that may be affected by the code in the ISR. It must be terminated with the instruction RTIE. Now we will begin with the tactile switch. I don't have any idea before this internship about tactile switch. When I little know, it was a very interesting. A tactile switch allows electricity to flow in an electrical circuit by manipulating pressing the operating section. The switch activates when pressed and then turn off when released. In matrix keypad, we need to configure rows as the output and column as the input. When designing pull down interface, R1 is 10 times greater than R2. So here it is a tactile switch look likes. Okay. So triggering methods are edge triggering and level triggering. We have already learned more about it in digital electronics as we are much aware about it. And there is one more effect which is called bouncing effect. There is a metal plate and terminal and pulse detection releasing the tactile switch is called as a bouncing effect. So here we begin with matrix keypad. In our microcontroller PIC 16F877A, we are seeing much use of a matrix keypad and its working is much unique and used when more number of user input is required and still want to save the controller input line. In our day-to-day life, we are much aware about matrix keypad. It uses the rows and column concept, most commonly used in telephone, digital local, calculator, etc. In cooking mode, the matrix keypads are used to select the respective word micro mode. So we will see in our execution of our project. Now timer. Timer play a much important role in microcontroller. So here we have seen that it's how it's block diagram and it's working that. So there are three types of timer we have used in PIC 16F877, timer 0, timer 1 and timer 2. Timer can also work for counting the internal and external pulses. Timer 0 is an 8-bit timer. There are various registers associated with timer. Register like TMR0, that is timer 0, clock source selected bit. For our project we have used timer which is also 8-bit timer. It has a period register to store a value in it and a timer that count tills the value. So we will understand the architecture of a PIC-SIMLab stimulator. So here is an architecture of a PIC-SIMLab stimulator. The MAM has taught each and every pin and its working and its tools very properly. In our execution of project, I will also let you know that how it's work. So this now we begin with our microwave oven project. That microwave oven is used to heat the food using the microwave, which is in form of electromagnetic wave. There are several modes in microwave. Here the microwave look like there are four modes: micro mode, grill mode, convection mode, and start mode. So we will show what are these modes and how they work. So micro mode, this mode is used to cook the food in traditional way. It uses maximum power of 90 watt. In this, maximum time set for the cooking is 60 minutes. Grill mode. This mode is used to cook the bread and meat. It works micro mode, but the purpose is to cook and bake. User can set time as per the cooking time of the dish in grid mode. So now begin with an convection mode. In this mode, user can set the oven to heat for a particular temperature. Here we will enter a temperature. After a preheating is done, then the user can set the time as per the requirements. So let's get into our project demo and so. So here I will going to open my MPLAB XID. So I had already built the project which is microwave oven. Here I had also made 4-bit driver, 8-bit driver, LEDs, level detection, microcontroller driver, 1 second timer to 1 second time prescaler and state change detection as ma'am taught us. These help us to understand our project very properly. are much aware about each every component. So here microwave oven project is already built. Here I made MNC file, mn.file. So let's see our code. So it begins with a so the code look like for microwave, and here we have using video display can and much more. Operation plus grill mode, it helps us to understand the use of language very carefully and properly. So this is my code, and it is my main.h, that is micro mode. We have defined for power on screen, menu display screen, micro mode, reset mode, and everything. So now let's begin with our PiximLab stimulator. So it's already shown. So first of all, I will say that what are the components using microlab. I meant to say PiximLab stimulator. So here these are the matrix keypad, and 1 2 3 4 these are the textile switches which are used in PiximLab stimulator. Okay, here is an reset key which is used to turn on and off the PiximLab stimulator or our microwave oven. So here it is a cooler which is used to cool the a particular dish. Here heater is also there, and buzzer will let us know that time is up. So here again is in switch RB3. So here it will begin with in switch RB3, which is used to know that microwave door is open or closed. Here are they all are LEDs, and this is our CLCD screen, which is also 16 into 4 and 16 into 2. Here we have used 16 into 4. If we use 16 into 8, it will not show our full information. So let's reload our file. Reload last. So it is showing that powering on and microwave. So it is showing the 4 modes: micro mode, grill mode, convection mode, and start mode. So let's begin with a micro mode. It is showing that power maximum 90 watt. In micro mode, when we press tactile key 1, it will on micro mode, and maximum power is 900 watt. Maximum time to cook the food in micro mode is 60 minutes. Buzzer will let us know that time is over. So here I will enter a short period of time, just 22 seconds, and I will enter the key hash. So here we can show that the fan is on or cooler. So after the time is over, buzzer will let us know that time is open. Here we can also pause it by pressing the tactile key 5. So here it is pause, and we can also resume it by pressing the key 4. So here it again begin. So here it is showing that time is up, and buzzer let us know that our cooking is done. Now let us begin with grill mode. So in grill mode is used to cook food for more than 60 minutes. Time is not limited here. When we press the tactile key 2, it will on grill mode. After 20 seconds, buzzer will let us know to turn off microwave oven. So here I will enter 21 seconds, and when I apply hashtag enter key, it will by pressing the star key, it will clear that. Let us see. So here it is clear. Now we will again press 22 seconds after hashtag entering. So it again is busy. When I press 6, it stops and comes to the menu display screen. So let us again begin with grill mode. So grill mode, let us again set the time 22 seconds and hashtag enter key. Now we will see that what will happen after the time is over. So here we can again show the time is up. It is much more similar to micro mode, but we can enter the time more than 60 seconds. Here there are relay switches uh, which acts as a switch for on and off purpose. Cooler is used for cooling the microwave. Now let's begin with our convection mode. So in convection mode, hmm, after in convection mode, heating time is very less, not more than 10 minutes. Now we will enter time 20 seconds. Now we will enter the temperature 123. And the convection mode is mostly used for the preheating of an oven. So here we can see that we have set the temperature 123. So let us enter hashtag. It will begin from 3 minutes, that is 180 seconds. So here we can see that. So it will take much more time. So let us begin with our convection mode. So here we can enter the temperature of our convection mode. So let us see again the convection mode. It is asking for our temperature 123. As I press hashtag enter, it again show that the preheating and the time is from 3 minutes, that is almost 67. So it will take much more time. After that it will let us know that how much minute you want to cook the food, and we can enter the temperature. So now we'll begin with our start mode. So again we're showing a powering and micro key because I had pressed the reset key. Now I had entered tactile key 4. So here it is begin with 30 seconds. If I want to increase my time by 30 seconds, I have to press the tactile key number 4. So let us see that the time is increased by 30 seconds. If I press the key, tactile key 5, the time will pause, and if I press the tactile key 6, it will stop. Now let us resume it by pressing the tactile key 4. If I again press the tactile key 4, it will increase the time by 30 seconds on entering 4 number key. Here, after the time is completion, here cooler is on. So let us wait. So here the buzzer is used again, and it will let us know that our cooking is done. So this is the working of a microwave oven, which we have done using MPEG Lab Stimulator and MPEG XID. So we have already shown the code here. So I would like to thank Rajnish Inderman for providing such an opportunity to work on a microwave oven project and whole EMERTEX technology team. So thank you so much, man, for providing this opportunity.